So in this particular lesson, we are still looking at application of differentiation. We are going to be looking at what it means if you have been asked to find a relative extrema of a given function. Okay, an extrema, we are simply trying to talk about the relative local minimum point of a particular function, or the relative local maximum point of a particular function. So when we say extreme, we are simply trying to see where the curve is increasing, where it is decreasing. Okay, that's really something that you must be able to know. Now, it depends with the instruction that you have been given by the question. You can be asked to find the relative extrema of a function using the second derivative. Of course, we use the second derivative because the second derivative is what is going to tell you whether the nature of the root of the points that you're going to find, whether your curve is going to be increasing or it will be decreasing. It's very important. Now, I'm going to show you very simple steps that you're going to be using whenever you want to find extreme of a given function. Let's start. And of course, if you want to register for personal lessons, make sure you inbox me on this WhatsApp number, +2 60777 66 40 46. Okay, that's the number that you need to contact me on. Let's begin. We find the relative extreme of the following function using the second derivative. The function that we have been given is f of x equal to x to the 3 minus 3x to the 2 minus 24x plus 32. Let's find the first derivative. Then this implies that f prime or dy dx is equal to, this is going to be 3x to the 2 minus 6x minus 24. From there, we need to find the critical points. So from the first derivative, find the critical points. So the critical points are going to be found at some point where f prime is equal to 0. Then from there, we can just divide everything by what is common. So this is going to be 0 is equal to x to the power 2 minus 2x minus, okay, what is 3 into 24? This is kind of more like 8 or something. Okay, let me just, okay, so 24 divided by 3, 8. I want to make a mistake. Okay, then from there, we can find the product, the sum. Product is equal to negative 8. The sum is equal to negative 2. The factors are going to be, which number if we okay, negative 4 and 2. Let's see. So if we multiply negative 4 by 2, we'll be getting negative 8. If we add negative 4 plus 2, we'll be getting negative 2. Okay, cool. So from there, we are going to have x to the power 2 plus 2x minus 4x minus 8 equal to 0. Then x is common, x plus 2. Negative 4 is common, x plus 2. Okay, so this holds. So our critical points are found at some point x plus 2, then x minus 4 equal to some 0. Then x is going to equal to negative 2. Then x is going to equal to 4. So the first derivative should be able to give you critical points. The first derivative should be able to give you critical points. We have found the critical points. Now we get the second derivative. Now, dy over dx2, we now get the equation, the first derivative, which is this. Then we find dy dx again. This is going to give you 6x minus 6. Now, when you reach here, in the first lesson, I had already shown you that whenever your d power 2x over dx to the power 2 is less than 0, your curve is going to be like this. Then it implies that you have a maximum value here. But if your d over dx2 is greater than 0, your curve is going to be like this. Then it implies that you have a minimum point here. So the critical points that you found are what you shall be using to test. So let's try to test. This is supposed to be d to the power 2y over dx to the power 2. So now let's test what it is. I'm going to get 6, then I'm going to put negative 2 here. Notice that I'm getting negative 12 minus 6. Then this is giving me like minus 18. Notice that d 2y over dx2 is equal to negative 18. Negative 18 is less than 0, right? Negative 18 is less than 0. So this implies that at x is equal to negative 2, we are having a relative maximum point. We're having a relative maximum point. So the maximum point is going to be at negative 2, comma, then you get the original equation, you put your negative 2 here, negative 2 here, is going to belong negative 2 here, plus 32. Let me just write everything. Otherwise, this is actually very simple. You get your y is equal to negative 2 to the power 3 minus 3 negative 2, 24 negative 2 plus 32. Now let's try to check what are we going to get. So negative 2 to the power 3 minus 3 negative 2 to the power 2 minus 24, then negative 2 plus 32. So this is giving us y is equal to 60. So at the maximum point is at some point negative 2 comma 60. Simple. That's how you solve this. Now let's try to check the second one. The second one, we can try 4. We see what 4 is going to give us. What are we using to test? We are using the same thing to test, the second derivative, which is this equation. So this is going to be d squared of y over dx to the 2 is equal to, while there is x, I'm going to put a 4. Then this is going to be like 6 multiplied by this is going to be 24 minus 6. Let me see. 24 minus 6, getting 18. So you get your 18, right? Now look. Your d power 2 of y over dx to the 2, this time around is greater than 0. When it is greater than 0, you're having a minimum point here. So the minimum point is at some point 4 comma, then let's try to put our 4 into the equation. You get the critical point, you put it directly in the equation, you see what you're going to get. So this time around we have y is equal to, let's find the y value, so it's going to be 4 power 3, then 4 to the power 2, 24, 3 plus 32. Let's see what we are going to get. So open bracket 3, so open bracket 4 to the power 3 minus 3, 4 there, power 2, minus 24, open bracket 3, plus 32. Sorry. So 4 to the power 3, minus 3, 4 to the power 2, minus 24, open bracket, 4 inside, plus 32. Okay, I get 48. So this whole thing is y equal to 48. So at 4 comma 48, at 4 comma negative 48, we are having the minimum value. So this is the maximum extrema point. That's the minimum relative extrema point. That's how you will be able to solve this. It's actually very simple. Let's do the second one, just for the sake of clarity and assurance that we have understood what we are doing and we are not guessing. So we have the function of f of x is equal to x to the 2 minus 16 over x, right? So we can find dy dx of this. And of course we know that f prime, which is dy dx, is equal to 2x minus, then this is going to be minus 16 over x to the 2. So f prime is equal to 2x plus 16 over x to the 2. We make f prime equal to 0. We get the critical points. Goes this side, it becomes negative 2x is equal to plus 16 over x to the 2. Want to get the critical points, we cross multiply. We are going to get minus 2x to the 3 is equal to 16. Minus 2 minus 2, x is equal to x cubed is equal to negative 3. We find the cube root of negative 8, and your x is equal to negative 2. Okay, so you have a point there, x, a critical point, x is equal to negative 2. I think this one should even be very easy. And we find the second derivative. The second derivative, we are just finding dy dx of the first. So the first was this. So the second derivative, we find dy dx of this is going to be 2 minus the same 16, but this time around to the 3. We shall be using this to be able to test whether it's going to be a minimum or maximum point. How do we do that? We are going to get a 2 minus then 16 over, we get the critical point. What is negative 2 to the power 3? It's going to be 16 over negative 8. So it's going to be 2. This and this will cancel. This is going to be like plus 2. Okay, then this will be like a 4. Let me just try to confirm. 2 minus 16 all over by minus 8. Okay, yeah, it's a 4. Now notice that 4, notice that when you get the minimum point at some point dy over dx to the power 2, when it is less than 0, that's when you get the maximum point rather. The curve is going to be in this way. The maximum point is found at this point. But if you have dy over dx to the 2 greater than 0, you have a minimum point at this point, right? Now, because in this case, we have found 4, so meaning d2 over dx2 is actually greater than 0. So we have a minimum point. So we have a minimum point at -2, comma, we get whatever we have, we put it in the original equation. Okay, we get what we have, we put it in the original equation. So the original equation was -2 power 2, which is this one, minus 16 over -2. So this is going to be like 44 plus this is going to be like 8. So y is equal to 12. You have a minimum point at that. You can do C. I can start for you. So in case maybe you want to part them up, you want to separate them, of course your C is just x over, okay, all over 1 plus x over x to the power 2. Let me see if it will be able to hold. So this won't be able to hold. So that basically means you'll be using quotient to be able to find dy dx of that. Or you can use your chain rule where you're going to say x, then open bracket 1 plus x to the 2 to the power -1. Use your chain rule. Here, rather product rule, okay? Product chain rule. And then you'll be able to find your things. But this is how you are able to find the relative maximum extrema point, relative minimum extrema point. Thank you so much.